we started off with the types of numbers. Your natural numbers starting from 1, your whole numbers including 0. You don't get to integers until you get to the negatives. And the negatives also include all of the wholes and everything else. Right? The rational numbers are your fractions. Right, Denicia? So you're supposed to know these sets of numbers. You remember them, Denicia?
Yes, sir.
Right, so these are the things that you had to know. Irrational numbers are numbers like that we don't really know the value of. Real numbers is everything. So this is where we kind of started off with, and then we started to talk about directed numbers in the last class, and we were looking at the rules for directed numbers. All of these rules are totally essential. So the rules for directed numbers here, you know, if the signs are the same or if the signs are different. The same signs, what do you do? Different signs, what do you do? Denicia, you know I'd be preaching about this almost every day, right?
Yes, sir.
But these things just apply to X as well and Y as well. Yeah, so don't feel that you could leave it in C-sec. No, the associative law applies here as well. Being able to add and subtract numbers in any order, especially when you're dealing with polynomials of X and Y. And how do we deal with polynomials? It have certain things that you could add. You could add and subtract numbers that are exactly the same. And I think we wrote it down over here somewhere. Right? We can only add numbers that are exactly the same. So our x could add to our x to give you 2x. Our x squared could add to our x squared to give you 2x squared. But you can't add, let me see, you can't add our x to our y though. Or you can't add our x to our x squared. X plus x squared, you can't add that. Yeah? So polynomials, we talked about all sorts of different things. And we talked about with multiplication and all of them kind of thing as well. So only numbers that are exactly the same. You know, if you have z to the power of fifth plus 2z to the power of fifth, you have 3z to the power of the fifth. Right? I plead the fifth. So then we talked about, well, we did some questions here. Let me ask you something, Sydney. You do your homework or? We will get back to that. Yeah. We have directed numbers here. We're talking about multiplication and division of polynomials now. And well, we had to review those rules for multiplication and division. If the signs are the same, you know, or if the signs are different, the answer will be negative. The same thing applies with polynomials as well. We talked about squares and why it is you could never have the square root of a negative number. So all of these things we covered in the last class, and basic polynomials we did as well. We even talked about fractions, and we looked at some interesting things with fractions, and today we are going to look at more fractions. Right? Remember when we spoke about these rules when it comes to separation of the denominators? A denominator must always be seen as the whole. Yeah? So you could take this and you could separate it by the numerators. 6 and you have y over here. But notice the denominators are the same. Yeah? So you must always separate it as the whole. And this was the example as to why. This is the example as to why. And we had another. And you see this here? We're going to need to use this today. So we're talking here about, you know, the laws of indices, which is a spin-off of multiplication and division. When you're multiplying a number by itself now, especially if it comes with an unknown, then we're talking about indices. Right? And we have all of these laws here. And I'd like you to remember laws like this one. That if you have a square root, that is to the power of a half. Or if you have a cube root, that is actually to the power of a third. And then we have this magical one here. That if you have x to the power of 2/3, always see the denominator as the root. So in any case, it's the cube root you're dealing with. But it could either be the cube root with the square outside, or it could be the cube root with the square inside. And I think that this is an amazing rule, that if you have a cube root, or even a square root, or a fifth root, or whatever kind of root, if you have a root with the square inside, that is the same thing as having the root of x with the square on the outside, which is amazing. That is amazing, right? That is some cool stuff there. We talked about commutative law and thing and laws of indices, and then we have the laws of indices questions here, right? So should we correct the questions now and then move on, or should we move on first, finish all of this stuff, and then correct everything at the end? What do you think? What do you want to do? Right? This is just a real quick, interesting little things. You don't even have to write it down. Just write what you need, right? It's always there in the Google Classroom. But you know, associative property of addition, you can add numbers in any order as long as you keep the sign, right? The associative property of multiplication is pretty much the same thing. Yeah, add numbers in any order as long as you keep the sign. The commutative property of addition and multiplication, well, I mean, you don't really need this. Then you have the distributive property of multiplication over addition, and that is that you can have an addition inside of the brackets and you could multiply throughout the brackets. This is the distributive law, right? So the distributive law is what we're looking at. Right, this one here might be a little bit new, but this is super, super important. So please make a note of this, right? So, and it's very, very basic stuff. The identity, right? The identity for addition is 0. What is identity? Identity, the identity of addition, and you can have multiplication. So you have the identity for addition and subtraction, and then you have the identity for multiplication and division. The identity is that number that when you carry out the operation, nothing changes. Yeah, just a reminder. This is an important thing, right? So the identity is that number which in addition and subtraction is 0, right? So when you add 3 to 0, nothing changes. That is still 3. When you subtract 0 from 3, nothing changes. It's still 3, right? But of course, if you do that, it's still negative 3. It'll remain negative 3. So 0 is the identity of addition and subtraction. 1 is the identity of multiplication and division. 3 multiplied by 1 is still 3. And 3 divided by 1 is still 3. So identity is something that you should know and keep in mind. The additive inverse is the opposite of a number, right? Any number plus its additive inverse always equals the identity. So, on a basic level, we saw the additive inverse was subtraction. But essentially, any number, a number added to the additive inverse, or not even added, we'll use this symbol to mean an operation. Right? So some operation, these are the operations here: add, subtract, divide. So number with the operation, if you carry across a number added to its additive inverse will give you the identity. So for example, if I have 3, the operation is a plus, and the additive inverse is the opposite of this number. So that would be minus 3. I will get the identity for addition, which is 0. Yeah. If I had 3 multiply by a third, yeah. So this will be the inverse or the reciprocal. So this one is the additive inverse. This one here you can say is the multiplicative inverse, also known as the reciprocal. So the multiplicative inverse or the reciprocal will give you the identity, which is 1. So you have the inverses of a number. And of course, the same thing goes with x, right? So with polynomials now, if I have a x plus a minus x, that will give me the identity. Or if I have a x multiplied by a 1 over x, this is the inverse or the reciprocal of x. For multiplication, it'll give me the 1. Nice. Well, now is the time to jump, almost time to jump into the deep end of the pool. But let me talk about closure. Closure is when all answers fall into the original set. We're talking about set theory here. Right? If you multiply two even numbers and the answer is still an even number, like 2 times 4 is 8, therefore the set of even numbers is closed under multiplication, right? So the set of even numbers, So you're talking about a set, a set in set theory. We could represent it as a Venn diagram like that, right? That's not the universal set though, but let's call this set the set E, which is the set of even numbers. And this set have all even numbers in it. Is this set a closed set? Does it have closure? Well, under multiplication, is it closed under multiplication, right? So, you have 2, you have 4, you have 6, you have 8. You have all of the even numbers in here. You have 10. If it is that I take 2 and multiply it by 4, 4 2s are 8. The answer is still in this set. So that means that this set is closed. The set of, this, I forget my set theory, the set of even numbers is closed under multiplication. Now note that if you could find any one example that will give me an odd number, well then this entire set is not closed anymore. So that is the concept of closure. Could anybody tell me, is this set, the set of even numbers, is this closed under addition? It very well may be, because if you add 2 even numbers, you'll get an even number. You can't really add 2 even numbers and get an odd number. So it will be closed under addition as well.
No, sir.
It could never be, it could never be, because a prime only have, like, say 7 is a prime. That's because the only factors of 7 are 7 and 1, right? 3 is a prime. The only factors of 3 are 3 and 1. If I take 7 times 3, 7 3s are 21. Right? 21 is not a prime because these are the 2 factors of 21. So now we're jumping into the pool. So we have some polynomial questions here, right? I'm gonna do the first one, and well, from here on in is just drills and drills and drills and drills. So we're gonna be talking about plenty drills, right? So this is where you will come in. Class doing all of these little rules. We talked about polynomials and how to handle different situations. Well, now we get to see if we could use all of these skills now. So these are polynomials. Polynomials mean many. Just take a look at number 1. Number 1, right? I have in brackets 7j cubed minus 2. Close brackets. I have a plus sign. And I have open brackets 5j cubed minus j minus 3. Very interesting. And separates numbers. I does always say that. Remember, I does always say multiplication and division glues numbers together, and addition and subtraction separates numbers. Alright, that is how you could have multiplication and division like a x multiplied by a y. We could write that as xy. Or if you had x plus y, it have nothing we could do with that. That had to stay how it is. Those two are separate numbers. But these two could be seen as the same number. So since it have an addition sign there, means that these two separate numbers, I do not need those brackets. Those brackets are just showing me that these are two separate polynomials, two separate expressions. So I could remove the brackets. 7j cubed minus 2, and then I can have this plus 5j cubed minus j minus 3. Now, keep in mind, if this was a minus over here, that minus would affect everything inside of here because of the distributive law. But we haven't reached that example yet. We're going to see an example like that just now. So far, because there's an addition here, that addition not going to do nothing inside of the brackets. It's not going to affect the brackets. So I could just remove the brackets comfortably. Right? Because that is plus, you could see this as plus 1 being multiplied by the brackets. So it's the same thing. Now polynomials come in. I see not only polynomials, but the associative law, right? So I could see here that I have a plus or a positive 7j cubed, and I have a plus or a positive 5j cubed. So because, remember the associative law says you need to keep the sign. You can add in any order as long as you keep the sign. So I could add my j cubes. 7, 8, 9, 10, 11, 12. So that is 12j cubed. Then I see that I have a minus j over here, and I don't have any other j's that I could add it or subtract it with. So that minus j will have to stay over here. And now you're seeing that I have, well, a minus 2 and a minus 3. And this is where those directed numbers rules just come in. Because when the signs are the same, I could add them. 2 and 3 is 5, and keep the sign. And so this is the answer. 12j cubed minus j minus 5, right? Which means that we can add numbers in any order as long as we keep the sign. So you notice I could add this 2 to this 3 as long as I keep the sign. It's really negative 2 minus 3. That is what that works out to be. Remember, we could see here that you could only add numbers or variables that are exactly the same. So you can't add the j cubed with the j. You could only add your j cubes together. Anybody have any questions? Anybody still writing? Nobody still writing? Well, now it's your turn. All right, so we did number 1. I have 1, 2, 3, 4 all you here because Joseph bailed out. So you have this 1, 2, 3, 4. These 4 to do right now. Plus a minus 6. That's looking pretty much like it, yeah. 8a to the power of 5. Right? And because of this plus sign separating them, I'll just throw away the brackets one time. Minus 4. And then I have plus 3a to the 5 plus a minus 2. So what we say in Indonesia is you can only add the a to the power of 5. You can't add it to this a. You can only add numbers that are unknowns that are exactly the same. So this is 8, 9, 10, 11. So 11, a to the 5, yes. Then this plus a is by himself or herself or itself or they self, I don't know. And then you have minus 4 minus 2. So minus 4 minus 2 is minus 6. Excellent job, Sydney. Denicia, you understand it? How do you feel about it?
To the power 5 plus 9m.
This one we doing? I'll just remove the brackets one time. So 6m to the 5 plus 1. Notice I could only remove the brackets one time because this is a plus here, which means that this is a plus 1. And plus 1 multiplied by this doesn't make any difference. You multiply some by 1, it becomes itself, right? So we'll see just now with the subtraction that the story is a little bit different, yeah? But plus 1 plus 2m to the power 5 plus 9m minus 1. And we can see we can only add the m to the 5, so 6 and 2 is 8, m to the 5 plus 9m, that I have nothing to add to, and then plus 1 minus 1. The signs are different, so you find the difference, which is 0, and keep the sign, 0. You don't really, 0 doesn't have a sign, right? So this is your answer. Excellent job, Shreya. Sarah, what's yours?
12m to the power 5 plus 3m minus 1.
All right, and Denicia, yours coming up. You could feel free to be wrong, eh? I hope you're not like anxious and thing. Nah, if you're wrong, that's totally cool. All right, these 3m to the power 5 plus 1 plus 9m to the power 5 plus 3m minus 2. Yeah, you could only add your m to the power 5, so 9 and 3, 9, 10, 11, 12, so that's 12m to the power 5. You have your 3m here that ain't doing nothing. And then you have plus 1 minus 2. Well, the signs are different, so you find the difference, and you keep the sign of that larger number, which is the 2, right? The 2 is larger than the 1. Minus 8. Oh, and you get the hard one too. Minus 6x plus 6. She get the hard one. And look at that. She ripping up. Because that's looking like it. So I'm going to remove these brackets one time. So I'll have minus 5x squared. Should I give all of you that one? And then I have minus x plus 4. And then I have plus this plus sign here. And I have minus 3x squared minus 5x plus 2. Right? So you could add the like terms, which is a minus 5x and minus 3x. This plus doesn't really make a difference with that minus. That minus just kind of dominates there. So it's like if that plus is not even there really. Right? This negates the addition. So you have 5. Well, the signs are the same, so you notice with directed numbers here again, even though it's x squared, right? Signs are the same, so you add them, minus 8, and you keep the sign. Excellent, right? Then you have, the x's. We have x's that can add now, and the signs are the same, so you add them and you keep the sign, minus 6x. And then 4 plus 2 is plus 6. Excellent job, Denicia. Subtracting polynomials, and it's a little bit tricky. So I have two expressions here, and well, you can see it have a minus. So I'm just gonna write it on this side here. You can see me writing it in white, but I'll move it. Minus x squared plus x minus 4 in brackets minus in brackets 3x squared minus 8x minus 2. U was the distributive law, right? So I kind of assume that you all remember a distributive law because this subtraction here changes everything. This subtraction, you could see this as being a minus 1 in front of this brackets, this second brackets. So that minus 1 going to change the sign of everything in there. The first one is not going to change, so I could remove those brackets, no problem. Minus x squared. It don't have anything in front here, so it's considered to be a positive, right? Minus x squared plus x minus 4. But look at what's going to happen now. This negative going to change the sign of everything that's in here. So negative 1 times 3x squared will give me negative 3x squared. Negative times negative 8x will give me positive 8x. And the negative times negative 2 will give me positive 2. So when you have a negative in front of the brackets, it's kind of like if all of these signs inside of the brackets just switch to the opposite. Now we could add our polynomial. So we can see that x squared is a minus 3. So minus 3 minus 1 gives us minus 4x squared. We have a plus x, and a plus 8x will give us plus 9x. And then we have a minus 4 and a plus 2. When the signs are different, you find the difference and you keep the sign of the larger number. So that minus there in front of the second polynomial does change things a little bit. But if you know your distributive law of how to multiply out, you're literally multiplying everything in the brackets by the negative. And yeah, that's okay if you got it wrong though. That's okay, that's fine. So we have minus 2x cubed plus x in brackets. And I have minus 7x, well, open brackets, 7x minus 3 minus 7x cubed. That is it, right? That is the one? Yeah? All right.
Yes, sir.
So let's see what's going on. Well, I could remove the brackets from this. It don't have anything in front of it. So that is a minus 2x cubed plus x. But then this minus going to mess with everything in here. So this minus multiplied by the 7x will make it minus 7x. This minus multiplied by the minus 3 will make it plus 3. And this minus multiplied by the minus 7x will make it plus 7x cubed. Right. Now we can see that I have a plus 7x cubed. Remember, with the associative law, you have to include the sign. A plus 7x cubed minus 2. 7 minus 2 is indeed 5x cubed. Then I have here a plus x minus 7x. So this is plus 1 minus 7. When the signs are different, you find the difference and you keep the sign of the larger number. And then I have plus 3. Yeah. Okay. One little mistake you made. Or I wonder, yeah. Minus x, this is plus 1 minus 7. You see that, Denicia?
Yes.
Yeah, so when the signs are different, you find the difference. So you see how the SCA rules. The little SCA form one thing does affect you in add maths, ain't? Yeah?
Yes.
Yeah, that is where the problems has come from. Trust me. But I'm glad you make that mistake though. It actually illustrated how easy it is to make mistakes. Remember, what we do in here is we just learning the moves, you know. We are start to play the game yet. We just learning the moves. When we do remainder and factor theorem, well, that is when we starting to play the game.
2x cubed plus 10x squared minus 6x plus 9.
That's what I have there.
Mm.
All right, let me see. 3x cubed plus 3x squared plus 9. And then I have minus 5x cubed minus 7x squared plus 6x minus 9. Move these brackets here, 3x cubed plus 3x squared. And remember, even if you did not do this question, you should be writing it down and paying attention and understanding it, right? This minus here will make this a minus 5x cubed. It will make it a plus 7x squared. It will make it a minus 6x, and it'll make it a plus 9. So you can see this minus here literally changes the sign to the opposite of everything inside of them brackets. So now I could say, well, 3x cubed minus 5x cubed, when the signs are different, you find the difference, which is 2. 5 minus 3 is 2, yeah? And you keep the sign at the larger number. So minus 2x cubed, right? I have 7 and 3 here. So 7 and 3 is plus 10x squared. I have a minus 6x here, minus 6x. But I see I have a plus 9 from here. And then I have this minus 9 became a plus 9. So 9 and 9 is plus 18. Did you get plus 18? Ah, so how come you miss out one of the 9s? What went on there? You forget one of the 9s. So that is what we call a careless mistake. Careless mistakes happen all the time, and I would say that it is the most dangerous mistake, because a careless mistake doesn't spare anybody. It could happen to a brilliant student, or it could happen to a moderate, mediocre student the same way. Yeah. If I'm going too fast, let me know. 5x cubed plus 5x squared plus 5 minus 6x cubed minus 6x squared plus 8x minus 5. I have 5x cubed plus 5x squared plus 5 minus 6x cubed plus 6x squared minus 8x plus 5. Right? So now I could see that 5x cubed minus 6x cubed, well, the signs are different, so the difference is 1, so it'll be minus x cubed. 5x squared plus 6x squared is indeed plus 11x squared. I have a minus 8x over here. And then I have 5 and 5 is 10 in. All right, so that's an excellent question, right? And I didn't even realize that it had this right answers in descending order thing. But when they're talking about descending order, generally what they're talking about is, and you probably wouldn't know this, but generally what they're talking about is the powers. Right? The powers are in descending order. This is x to the power of 1. And over here, we have x to the power of 0. Yeah. Right? So the powers are usually in descending order. That's an excellent question. Thank you for reminding me, because that is one point that I was supposed to make, and I, just forgot to make that point.
2x cubed plus 12x squared minus 8x plus 10.
Wait, now my camera. 5x cubed plus 3x squared plus 5 minus 7x cubed minus 9x squared plus 8x minus 5. So yeah, I could just remove the brackets. 5x cubed plus 3x squared plus 5. But this minus gonna mess things up. Minus 7x squared plus 9x squared minus 8x plus 5. And now I could see I have 5 minus 7. When the signs are different, you find the difference. You keep the sign of the larger number. Wait, no. Oh, yeah, is it? Yeah, 7x cubed. Yeah, this is cube here. So you keep the sign of the larger number. Then I have plus 3 plus 9, 10, 11, 12. So yes, plus 12x. I have this minus 8 here. And then I have 5 and 5 is 10. Excellent job, Shreya. So anybody have any questions? Of course, we do have the easier ones to finish off here. X cubed y squared multiply by minus 3x squared y cubed. Notice something. Notice that inside of these brackets is multiplied. This is 8 multiplied by x cubed multiplied by y squared. Inside of this brackets is all multiply. Yes, the 3's are negative, but it's 3 multiplied by x squared multiplied by y squared. Remember what I said? I said multiplication glues numbers together. So that means that this could be seen as just one number. This could be seen as just one number. So you can see here that we have a positive number multiplying by a negative number. So you know your answer gonna be negative one time, right? So where's 8 threes? That's 24, right? 8 threes are 24. 1 3 is 3.
Yes, sir.
Right? So that's gonna be 8 threes are minus 24. Then you multiply the x's. So I could not have added x cubed and x squared. I can't add that, no. But because of my laws of indices, I can multiply them. X cubed multiplied by x squared. Well, you add your indices, right? X to the 5th. So x cubed times x squared will give me x to the 5. And then y squared times y cubed will give me y to the 5. Something. But 4x minus 3. And then you have 3x minus 5. It have 2 ways to think about doing something like this. 2 ways, right? So it have 2 ways. Right? So the first way, remember how, and I'll just do it in my working column here. Remember how if you have 2 multiplied by x plus y, you just take the number outside of the brackets and multiply it by everything inside of the brackets, right? So you could take this entire thing here as being one number because it's in brackets. So because even though this separation, this minus sign, separates the 4x and the 3, right? These brackets here make it one expression. So you could treat it like one number. So this one number multiplied by the 3x. So that you have the one number 4x minus 3. And you're multiplying it, you're multiplying it by the 3x. And then you have this minus sign. So you had this minus sign there. And then you have this number multiplied by the 5. You already put that minus sign there, so you could just put the 5 multiplied by the same number. So this is one way to do it. And then you just kind of do them individually. So 3 4 3s are 12x squared on this side. And then you have 3x times minus 3 is minus 9x. And then on this side, I have to count the minus 5 times 4. 5 4s are 20. There's minus 20x. And then minus 5 times minus 3. 5 3s are 15. It'll be a plus 15. So now I'll have 12x squared. This minus 9 minus 20 is minus 29x plus 15. So that is the first way to do it. Any questions on the first way? And that is when we have the 4x minus 3. This is the way I is used. I think it's just quicker. It's the quicker way to do it, but you just kind of had to be careful, right? If you look at it, you know, this 4x is multiplying by the 3x here. The 4x here multiplying by the 3x here, right? And then you have this 3 multiplying by the 3x. So this 3 multiplying by the 3x. And then, you know, across here, you know, that kind of thing, right? So this is how you...
Foil.
Sorry?
Yes, so that way you can use?
What is the acronym? What does FOIL mean? I don't think I've ever heard of FOIL.
So it's like first term by first term.
Oh, yeah, that one. Yeah. So you multiply every single other term, right? So, all right, so this is how I just do it. I will take the first term and multiply it by everything in the next brackets, right? So 4x multiplied by the 3x. 4 3s are 12x squared. Then I will take the same 4x and multiply it by the minus 5. So 5 4s are minus 20x. So I finished with the 4x day. The 4x was successfully multiplied by everything inside the other brackets. So now you take this minus 3 now. Minus 3 times 3x will give me minus 9x. And you know, you're taking the minus 3 and multiplying by everything in the other bracket. So minus 3 minus times minus 5 will give you a plus 15. And look, you know, you have one step less. 12x squared minus 29x plus 15. What did you call it? FOIL? What does FOIL mean? I never heard of FOIL, you know. That's a new thing, oh.
So it means the F will be first term by first term, and the O will be outer by outer. The I will be inner by inner, and the L will be last by last.
Yeah, that harder. I now know why I probably never learned that, because that harder. Nah, just as a visual guy, just take the first term and multiply it by everything in the next brackets first, and then take the second term and multiply it by everything in the next brackets, and you're gonna be good to go. Yeah, that FOIL thing was just looking a little bit
So well, it's basically the same thing, you know.
It's basically the same thing, but I mean, oh gosh, unless you learn it procedurally, that sounds quite a bit complicated to me. All right, Joseph, you missed out on a lot of stuff, bro. But thank God we're recording these classes, right? Do this one. Let's do this one. And let's do this one. All right, and you can see here that, you know, we have 3 there. So, oh my God, so you can just take the first one and multiply it by all 3, and then take the second number and multiply it by all 3, right? So those are the 4 we do, and everybody has to do all 4 this time. So just say done it when you're done it. And I wouldn't call no names. I will just do them. I will just correct them. So just say done it when you're done it, right? I have negative 9x cubed y, and that being multiplied by negative 8x squared y cubed. And notice that it don't have any addition or subtraction inside of these brackets. Yeah, the signs, the numbers are negative, but it's not a subtraction, they're just negative. So where's 9 8ths? That's 56.
9 8s are 72.
72, yes, 72, right? I don't have my calculator on me. 9 8ths are 72, and it's going to be a positive 72 because I multiply by I multiply. And x squared times x cubed is x to the 5. And y to the power of 1 times y cubed is y to the power of 4. 5m squared, open brackets, 3m cubed plus 5m squared minus 4m plus 6. So this is a kind of distributive law. So it's a multiply. You're multiplying 5m squared by 3m cubed. 5 3s are 15. And m squared times m cubed is m to the 5. Now you're multiplying 5m squared by 5m squared. 5 5s are 25. It's a plus 25. And you're going to have m to the power of 4. Now you have 5m cubed times 5m squared, times negative 4. So 5 4s are 20. It'll be a minus 20. M squared times m is m cubed according to your laws of indices. And then 6 5s are 35. 5 5 6 5s are 30. Oh my God, I am really in a bad shape today. 6 5. Thank you for reminding me of my timetable, Sarah. 6 5s are 30. And imagine this actually going on a video, eh? So the whole world will know that I suck at my timetables. So 6 5s are 30, m squared. Been making careless mistakes. And I think that is it. I don't think anything could add and subtract here. Because this m5 cannot add to the m4 or the m3 or the m2. Nothing could add or subtract there. So that is pretty much it. But you can see that I could factorize this to get back that. Yeah, I could factorize this to get back that. Because everything would have 5m squared in common. Well, it's a good thing I'm using the same Zoom link for all of the classes, right? So I'll have to show you. Please remind me before you go to show you the class code to get into the AdMaths classroom, right? That is no C. Number 28, we have 5x plus 4y. And then we have 2x plus 5y. Just remember, I'll just take the first number and multiply it by everything. So 5x times 2x, 5 2s are 10x squared. And then 5x times 5y is a plus 5y. So it'll be plus 5 5s are 25xy. Yeah. Now I've finished with the 5x. Now it's time for the 4y. 4y times 2x. 4 2s are 8. So it's plus 8xy. And yes, you could have put yx, right? Yx is correct. But generally with polynomials, when we're doing things like this, we like to keep it alphabetical. I think we talked about that last week. So we like to keep it in alphabetical order. All right? So if you have Q, P, S, you would want to write it as P, Q, S. You want to keep it in alphabetical order. All right? Not only that, but we notice that we have two sets of xy there. So those could be added, right? Now we have 4y times 5. 5 4s are 20. I got that right. 20y squared. So now I could see here that I'll have my 10x squared. 25 plus 8. Well, 25 and 5 is 30 and 3 is 33. So that is plus 33xy. And then I have plus 20y squared. That is the final answer. Denicia missed the first class, but she come in with some artillery here. She come in with ammunition. Last one, 2x minus 5 multiplied by 5x squared plus 4x plus 7. Again, I'll just tackle it the same way. I'll take this 2x and multiply it by everything first. So 2x times 5x squared. So 5 2s are 10x cubed. 2x multiplied by 4x is plus 4 twos are 8x squared. 2x multiplied by 7 is plus 14x. Now I have the minus 5. Wait, this thing gonna be long. I should have do it on the other side. Sorry if I crouching this up, guys. Let me use a thinner nub. Yes, hopefully I could squeeze it in a little better with a thinner nib. All right. So negative 5 times 5 is minus 25. And that'll be minus 25x squared. Negative 5 times 4, 5 fours are 20, that's minus 20x. And negative 7 times 7 is minus 35. 7 5s are 35, I hope so. So I only have one x cubed there, so that is 10x cubed, right? I have x squared, 8x squared minus 25x squared. What's the difference between 8 and 25? Anybody? Signs are different, so you find the difference and you keep the sign of the larger number. X squared, right? Then I have plus 14x minus 20x, so I'll get minus, the signs are different, so you find the difference, minus 6x. You keep the sign of the larger number, which is the minus. And then you have the minus 35, and that's it. And of course, I'll do one of them. Let me do this one. Right? I'll do these two, right? So minus 6, and that's being divided by 3. And by the way, the remainder and factor theorem is all about the division of polynomials. When you divide, the remainder of factor theorem is if I take this and I divide it by this. How do you do that? And I mean actually divide it, not just separate it, but actually divide it. The way you just had to do is you just had to do it with long division. To actually divide it now. Because we don't know how to actually divide these things, but we do know how to break apart fractions. Now let me ask you something. Can I say, Sydney, can I say that this 3 could cancel with this 9? Can I just say that? So I'll end up with what? 3x minus 6. What do you think? Can I do that? That was a yes or that was a no? That was a no, all right? So the rule that I wanted you to remember here is a rule we talked about in the last class. When you have two fractions that are being added or subtracted, right? All you had to do is add or subtract the numerators because the denominators are the same. So two fractions with the same denominator, right? So that means that the 1 will be added or subtracted to the 2, and both of them will be over the same denominator. So that is what's going on here. You have two numbers being subtracted, and they over the same denominator. So this is what I have right now. When I look at this is what I have. And I could go in the other direction. I could split them up and put the 1 and the 2 over the same denominator. So how I split this up, I could say, well, all right, that'll be 9x on 3 minus 6 on 3 over the same denominator. Yeah. So this will end up being, now I can cancel that and that. So I'll have 3x. Right? So 3 into 3, 1, 3 into 9 is 3. And now I have the minus, 3 into 3, 1, 3 into 6 is 2. 3x minus 2 is what we ended up getting here. So yeah, you could cancel the 3, but you had to cancel the 3 with both of them. And that is essentially it, that is essentially it. Let me see how much more we had to do. Well, we still have some stuff to cover here. Factorizing by grouping and all of that kind of stuff. And this is the end. We don't have to do Pythagoras and thing. We could skip this and the trigonometry. We go get there when we get there. So all we had to do is we had to do up to this factorizing by grouping there. I wonder if we could finish this today, boy. Yeah, we have half an hour again, right? So since we have half an hour again, I'll give you guys 2 questions.
Got it.
So this is the first one. And this is the second one. So you see how important your SCA fractions come in here? Because this little rule that we were talking about, that was a SCA rule. Yeah? This little rule here. Ah, not that one. Yeah, this little rule here. Is a SCA rule. So it came in quite handy, right? So 4 will cancel with the 4, and this will be x to the 8. Right? Laws of indices, when you're dividing, you minus the indices. So this will be x to the 8 minus, well, 5 can divide into 4, but this x gone, and 9 minus 2 this is x to the 7. So it'll be 5x to the 7 all on 4. It have another way to write this though. And then minus 4 into 4, 1, 5 4s are 20, x squared. 5x squared. Now we have another way to write it, and the other way to write it is by saying that is equal to x to the 8 minus 5 on 4 x to the 7 minus 5x squared. Knowing that this and this are the same is a very important thing to know, right? Very important thing to know, right? So just as a reminder as to why they are the same, and we did it in the last class, but I'm just reminding you, 5 over 4x to the 7, that is basically saying 5 over 4 multiplied by x to the 7 over 1, and you just multiply your numerators and your denominators to get 5x to the 7 all over 4. So just know that they are both the same. So you know you had to finish that for homework, right? Get your practice in, and we will spend one class. It looked like we'll have to spend one class doing all of the homework. I don't know if it'll be the next class because I am eager to test your skills when it comes to to the remainder and factor theorem, right? What we talking?
One thing to ask, just
Yes,
one thing.
yes, of course, of course.
The question said minus 5x squared over 4. Is it the same thing?
Oh, this one. No, well, minus 5x squared is something totally different from minus 5x squared over 4. Remember, the 4 cancelled, and so that 4 is not supposed to be there. Yeah. Yeah, that's all right. Yeah, I mean, oh gosh, you just make one little mistake. It has happened. It has happened. You understand it though? So let's go to the finish line with this class. So we was talking about essentially this stuff here. This stuff here is essentially the distributive law. And remember how I was saying how you could take, your answer and factorize it back and get back this? Well, now we're gonna talk about that factorizing, but of course, it's a slightly, one level up, right? And you can see in this example here, when it comes to basic factorizing, right? Basic factorizing. What is factorizing? What does it mean to factorize? To factorize means you're breaking it up into its factors. So for example, you have this 6, and I could break up this into 2 multiplied by 3. You're breaking it up into its factors. You notice what I ended up getting back is the distributive law, a number multiplied by a bracket. Right? So similarly, I have 2x plus 2y. And to factorize this, you need to ask yourself, what do they both have in common? And what they both have in common is the number 2. So you write the number 2. That is what they both have in common. And then you open your brackets. And then you ask, well, distributive law now, 2 multiplied by what will give me 2x? Well, that is 2 multiplied by x. And then you have a plus sign. And then 2 multiplied by what will give me 2y? Well, that'll be 2 multiplied by y. Notice that nothing inside the brackets, they have nothing in common. Nothing in common. If they still have something in common, that means you didn't factorize it well enough. Because once you factorize, inside of those brackets should not have anything in common, right? So let me just get some donuts for this note here, right? So of course, when we're talking about factorizing and add maths, we're talking about slightly harder polynomials, right? So we can see we have a polynomial 5x squared plus 10x. What do these two things have in common? Well, they have 5 in common, but they also have, you look for the lowest power of x. So you can see that is x. They also have x in common. Yeah. And I'll show you another example. Yeah. Let me see. Yeah. I'll show you another example. Not that one, but another one. Ooh, look, I have a slightly harder one here. Right. So I'll show you another example very soon. Right. 5x. They have 5x in common. So you pull 5x out and you open your brackets and you ask yourself, 5x multiplied by what will give me 5x squared? Well, 5x times x is 5x squared. I have a plus sign. 5x times 2 will give me 10x. And you could notice nothing in here has anything in common. So this was example 2. Any question? It's pretty much the same thing. 9x squared minus 3x. You ask, what do they have in common? Well, I can see they have 3 in common, right? Because 3 could go into 9 as well. And they have x in common. So 3x multiplied by 3x will give me 9x squared. I have the minus sign here now, right? And then 3x multiplied by what will give me 3x? Well, 3x multiplied by 1 will give me 3x. You could see that this guy, this one here is like a placeholder. Yeah. Notice these have nothing in common. Of course, they do get more complicated. You have these two here to try, but I mean, oh gosh, they're easy. But look at this. And then, well, you have these two here to try, right? So let's just talk about this one. 2x squared. Well, actually, you know what? Wait. Before we talk about this one, I have one more example that I want to give you here. So let's call this example 4. And let's say that I have 5x cubed minus 2x squared. No, not 2x squared, because that is nothing in, that's not in common, right? Minus 10x squared. All right. So you can see, what do they have in common? Well, they both have 5 in common, but they also have the lowest power of x. This is what I mean by the lowest power of x. The lowest power of x being x squared. So I could pull x squared out of both of them. And so now when I open it up, I could see, well, 5x squared times x will give me 5x cubed. And I have the minus sign. 5x squared times 2 will give me 10x squared. Yeah. So that is what I meant by you're pulling out the lowest power of x. So you can look for that lowest power. Don't just pull x out. No, look for the lowest power of x you have. And in this case, it's x squared. So that means you could pull x squared out. As long as everybody else have a higher power of x, then you could pull x squared right out. I have 2x squared y to the 5 minus 4x y cubed plus 6x to the 4 y squared. What do they have in common? The longer you take to answer is the longer we take to go home. We might have to go a little bit past 8 o'clock today. Let's talk about the number first, Denicia. What number do they all have in common? What number could I pull out of there? Now we're seeing that they all have x's in common. Where's the lowest power of x you have there?
Oh, I mean x.
Yeah, you're seeing that they all have x's in common. What's the lowest power of x? X squared?
X.
X, right? So it'll be x to the 1. And they all have y in common. So what's the lowest power of y? Right, so I could pull 2xy squared out. And now I could open my brackets. 2xy squared times y cubed will give me 2x squared. No, I'm wrong. Look how I get that wrong. 2xy cubed multiplied by x, no, 2xy squared, all right? So I have the 2 here, so I don't need to put nothing here, all right? The x times the x will give me x squared. Y squared times y cubed will give me y to the 5th. I have my minus here. 2 multiplied by 2 will give me the 4. X times 1 will give me the x, so I don't need to put no x there, all right? And then y squared times y will give me y cubed. And then I have the plus here, and I have 2 times 3 will give me 6. X times x cubed will give me x4. And then y squared, well, y squared times y squared. Y squared times 1 will give me y squared, so I don't need to put that there. All right? So this is what I end up with. Notice how nothing have anything in common inside of here. Yeah, right? I mean, yeah, two of them have x's, but not all three. Two of them have y's, but not all. Try this one. This one here. Try that one. Say done it when you're done it. All right. So let's check. All of them have 5. 5 is the lowest common factor. So I'll pull out the 5. A, all of them have A, and A to the power of 1 is the lowest power of A. All of them have B, and B cubed is the lowest power of B. So now I open my brackets. 5 times 3 will give me 15. A times A will give me A squared. And B cubed times B will give me B to the 4th. Minus 5 times 1 is 5. I don't need to write the 1. A times 1 is A, so I already have 5A there. I already have B cubed there, so I need to put 1 here now. Because 5AB cubed multiplied by minus 1 is what will give me minus 5AB cubed. Yeah, so I need to put that 1 there to have something to multiply with, right? Plus 5 4s are 20. A times A squared will give me A cubed. And B cubed times, well, this will give me B cubed. B cubed times 1. So I don't need to put the 1 there. Yeah. Plus, you know, so therefore, if I say 5AB cubed times 4A squared, I'll get 20A cubed B cubed. So you see how at maths things just get a little tricky, yeah? 5 2s are 10. A times A to the 4 will give me A to the 5. And B cubed times B to the 4 will give me B to the 7. And even though these two do have A and B in it, I wonder, nah, you can't factor it again. Right? Because the 2 and the 3 are not factors at all. So this number is what all of them have in common. Denisia, did you get it? Now, as I say, these last 2 classes here was just to build your skill. So you see how in today's class, we had to use all of the skills from the last class. So you best believe that the next class, you're going to have to be using all of the skills from this class. And this is the last skill that we're going to talk about here. Factorizing by grouping. Yeah. So, you know, you can see here I have 2x squared plus 8x plus 3x plus 12. Yes, I could add the 8 and the 3 to give me 11, but I'll leave them separate because now I have 2 groups. I have this group and I have this group, and they're separated by a plus sign here. I could actually work these 2 groups separately. It's called factorizing by grouping. Right? So I could actually say, well, you know what? Let me work this first group first. What do they have in common? Well, they have 2x in common. So 2x times x is 2x squared plus 2x times 4 is 8x. Now let me work the second group. The second group only have 3 in common, right? So 3 times x will give me 3x, and plus 3 times 4 will give me 12. Notice that what I want is I actually want the same factor in both brackets. So you had to try to work it that you will get the same thing in both brackets, and this plus sign comes here. So now one of the factors is x plus 4, and the other factor is this 2x and this plus 3, 2x plus 3. And this is what you get when you factorized it. And if I was to multiply this back out, I would, right? What you want is you want the same expression in this brackets, and you want the same exact expression in this brackets. So another way to do it, well, we gonna see. I know all you want to go, but we just had to finish this last one here. If we finish this, then next class we could move on, right? And of course, we will have to spend one class doing all of the questions. I feel after we finish algebra, the whole algebra section, we could take one class and come back to this first class and do all of the questions for all of the classes, a questions class. So all you better do all your questions. Right. So I have this example here, and let me try, I'll just try doing this example on the side. So 3x squared plus 6x plus 4x plus 8. And I could try factorizing by grouping. So I'll take this first group, and what you are going to do, I'm going to use a slightly different method this time. So check this out. This first group here, I have 3x in common. So 3x times x will give me 3x squared. And 3x times 2 will give me 6x. Now I know that on the next side, I want to get this same thing. So what I'm going to do is I'm just going to put this same thing here. I'm going to put this factor over here and ask myself, well, what times x will give me 4x? Well, it'll be 4, and then 4 times 2 will give me the 8. And of course, you have this plus sign here. So this is the other method where you work this one out first, and whatever you get in the brackets, just automatically put it here, because you know you want the same thing in both sides. So now my factors are 3x plus 4 and x plus 2. And it actually have questions in these. These are worksheets with questions. These links here. So when you click those links, and we had to look at all that, but we ain't gonna look at all that. You know, when we reach here, we go revise them things, and we are gonna reach there in a little while. Yeah. So that is actually it for our ADMAT prerequisite. And you can see that this prerequisite, we covered a lot of stuff, and plenty of this stuff had to do with SCA, plenty of this stuff had to do with CSEC. But you see, with ADMATs, we taking it to the next level, where we doing these operations using many numbers, X, Y, Z, A, B, and we call those polynomials. Polynomials means many numbers, right? This is the Google Classroom here. Under algebra, we just did this section. There are no videos in here yet, but by tomorrow, the video for the first class will be posted. And then before the next class, I will have the second video posted. So the first 2 classes will be posted in here. When you're looking for them, they'll be in here. The next class we're going to do is the remainder and factor theorem. I am excited because we are actually going to be starting our first real ADMATs topic. Yeah, so I'm quite excited to start the remainder and factor theorem there. Nice. So, unless there are any questions about anything that we did in the past couple of classes, that is it for today. So you all go and do your thing, and I'll see you all next Wednesday. Remember you have remember all you have questions. Just just now, remember all you have questions to finish out there. So make sure all you finish out all of these questions for question day. On question day, we are going to come back to all of it.